So let's diagram the relationship between enzymes and energy. To do this, I'm going to start with an X and a Y axis, and on my X axis, I'm going to label time, and then on my Y axis, I'm going to label it energy, which can be abbreviated just with capital E. And so in black, what I will do is I will start by drawing a chemical reaction's energy curve, and this is going to be under normal conditions, so without an enzyme. And so about in the middle of this y-axis, I'm going to put a little line. It's going to start straight, and I'm going to put an R there. R stands for our reactants. And then lower on the graph, and much later, we're going to have our products. We're used to seeing substrates and products, but for a chemical reaction, in general, we say that we go from reactants to products. With an enzyme, we go from substrates to products. But in general chemical reactions, we say reactants to products. So when we draw our energy diagrams, we're going to start at the reactants. And for these reactants to be converted into products, we have to add in energy. So we're going to draw a curved line upwards, and that's representing the addition of energy that we need to get this chemical reaction started. Once it starts, though, the energy level is going to decrease as the reaction becomes more stable and you wind up with your products. So there's that decrease in energy until you arrive at the energy state of the products. The energy here between the reactant level and the highest level of energy, that's called activation energy. And what that means is the energy required to start a chemical reaction. So activation energy is going to be very important. What an enzyme does is reduce the amount of energy that's needed to start a reaction. So I'm going to represent this by using a different color. I chose red, and red is going to represent the energy diagram of my chemical reaction with an enzyme added. So it's going to start at that same level because the reactants do not change, or those substrates do not change. But instead of going all the way up to the height of this graph, having an enzyme there is going to reduce the amount of energy that's needed to start a reaction. So here where I drew the little double arrow is showing you the activation energy required to start a reaction when you have an enzyme. So essentially, the important piece here is that enzymes catalyze, which again means speed up. Enzymes catalyze chemical reactions by lowering activation energy. So I'm going to make a super simplified version of this graph. X and Y axis with time on the X, energy on the Y, showing you what the curve would typically look like if you didn't have an enzyme, starting with the energy level of the reactants, ending with the energy level of the products, and with the addition of an enzyme, we are lowering our activation energy.